Hello friends, welcome to Math Wizard. Today we are going to study part 5 of the chapter Triangle, which is CBSE Standard 10 chapter 6. And today we are going to study two theorems and two examples relating to similarity theorem on area and altitude. Let us go one by one. Area similar triangle, and that is theorem 6.6, and which reads as the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Here two triangles are given to us, and we have been given these two triangles are similar. And what we need to prove? We need to prove that their area, means ratio of their area, is equal to any one of the ratio of their corresponding sides. That is, it can be either AB by DE whole square, or equal to BC by EF whole square, or equal to AC by DF whole square. Right? To prove this, we need only two construction of lookalike nature. We are going to draw perpendicular, that is AM परपेंडिकुलर टू BC एंड DN परपेंडिकुलर टू EF. ये दोनों परपेंडिकुलर या तो फिर अल्टीट्यूड या तो फिर हाइट, and this symbolizes angle M and angle N are 90 degree, right? Let's move. As because it is given to us, we can infer that AB by DE equals to BC by EF equals to AC by DF. That is ratio of their corresponding sides. Let us take it as equation 1. And from the data given and the construction, what are the data given? For sure, proportional of sides, it is given. Second, corresponding angles are equal. So when I see two smaller triangle, that is ABM and DEN, using AA criteria, I can say these two triangles are similar. And what is first A? The first corresponding angle set is 90 degree at M and N. Second one is that B and E, because ABC is declared to be similar with DEF. तो अगर ये दोनों सिमिलर है तो उसका कॉरस्पॉन्डिंग एंगल भी सेम होंगे, तो बी एंगल इक्वल्स टू ई एंगल. तो ये ए क्राइटेरिया के हिसाब से हम ये दोनों को सिमिलर डिक्लेयर करेंगे, एंड दैट विल बी आवर इक्वेशन 2. And from this, we can write that the corresponding sides of this smaller triangle are same. We are not going to consider BM and EN, but at least we can say AB by DE is equal to AM by DN. And AM DN are not only the sides of this smaller triangle, but also the altitude of the bigger triangle ABC and DEF. And we are making it equation 3. From 1 and 3, we can club all these three sides plus the altitude as proportional, and that will be equation 4. मीन्स इक्वेशन 1 में जो तीनों बड़े साइड्स हैं, जो बड़े ट्राइंगल के ए बी बी सी ए सी डी ई एफ एंड डी एफ, उसके साथ में चौथा एक जुड़ गया, अल्टीट्यूड. 4 इक्वेशन और फिगर समराइज करते हुए आगे चलते हैं. अभी देखेंगे हम जो मिल गया इक्वेशन 4, उसको कहीं ना कहीं यूज करेंगे. ठीक है, अभी निकालते हैं एरिया ABC एंड एरिया DEF. क्या होगा? We know the formula of any triangle, area formula, that is half into base into height. So ABC के लिए base होगा BC और height होगा AM. DEF के लिए the base will be EF and the height or altitude will be DN. So we can write this, nullify half, and remaining BC into AM divided by EF into DN. And this is my equation 5. Now, if I see equation 5 RHS portion, that is BC into AM and EF into DN, and we can relate to equation 4, In equation 4, all the numerators are same. That is AB equal to BC equal to AC equal to AM. Similarly, D equal to EF equal to DF equal to DN. It is not on the basis of their value. No. I can interpolate any of the two. BC and AM both are in numerator portion of equation 4. Similarly, EF and DN are on the denominator portion of equation 4. Right? So we can rewrite this particular thing by substituting the value in equation 5. Area ABC by area DEF, which is equal to BC AB into AB by DE into D, or we can say AB by DE whole square, and similarly we can say next side, that is BC by EF whole square or AC by DF whole square. And this is nothing but we are going to the proving element. We were required to prove this, right? Now on this basis, let us take an example. And the example reads, let ABC is similar to DEF and their areas be respectively 64 and 121 centimeter square. If EF, that is one of the side, is 15.4, find BC. Let us see whether BC and EF are corresponding. Yes, they are corresponding. We have been given with this data area of both the triangles and one of the side, and BC is the corresponding side of the side for which the measurement is given. So we can usually take down that data given, that is similarity areas and one of the side, and we need to show BC measure, and for this we can declare ABC's similar to DEF, and thus area ABC by area DEF equals BC by EF whole square on the basis of theorem 6.6. And if I interpolate all this value in equation 1, then we will be getting 64 by 121 equals BC by 15.4 whole square. And remind you one thing, whenever you are doing any mathematical calculation, please avoid writing those SI unit. We can put 100% without fail on the answer point, but not during the course of calculation. Remember this thing. So we need to square root both the side to get rid of the square, and hence we will get 64 by 121 whole root over equal to BC by 15.4. 64 and 121 will be neutralized to 8 by 11, and 8 by 11 will be always plus because this is only measuring. It is the measuring point, and any measure cannot be negative. So we can rest BC equal to 8 into 15.4 by 11. Further simplifying this, we can get 8 into 1.4, and that is equal to 11.2. And here the SI unit is centimeter. Alright, we need to work out this. Let us go to the next theorem, theorem 6.7. And this is altogether about any right angle triangle. This theorem is exclusively based upon the right angle triangle. Right? And it says if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to whole triangle and to each other. What it says, if ABC is a triangle and 90 degrees drawn at B, and we are going to draw a perpendicular on AC from B, that is BD perpendicular, then we get the original ABC triangle. Along with this, we get two right angle triangle, that is ABD as one of the triangle and BCD another triangle. And what the theorem says, all the three triangles, that is excuse me, the bigger one, the original one, and the smaller two, all are similar to each other. ABC 90 degree has been given. Angle ADB is equal to angle CDB is equal to 90 degree. That means that says BD is altitude to AC. that is also accepted. And we need to prove all these three triangles, the bigger one and the smaller two, are similar to each other. For this we do not require any sort of um, construction. Directly we can approach the proof part using theorem 6.3 AA criteria. We will be taking two triangles at a time. Let us first take triangle ABC and triangle ADB. To make it similar, what we need to know, at least two angles to be similar. And here, what are the angle? We do not know. We do not have any idea about the sides, but we do have certain idea about the angles. What are those angles? If I am going to use AA criteria, angle A is common in both the triangle, and angle B as well as angle D, both are 90 degree. So with this AA criteria, I can declare these two as similar. Second, from this what I taken, the bigger triangle and the other left out triangle. Same, here the common angle will be angle C, and angle B, angle D, both are 90 degree. And these two gives rise to this. Means here LHS both are having triangle ABC, so RHS are need to be similar to each other. And from 1, 2, and this is if taken 3, then from 1, 2, 3 I can infer this what I am supposed to be proved. Let us take one example on this. In the given figure, ACB 90 degree, CD is altitude to AB. Prove that BC square plus by AC square equals to BD by AD. Let us see the figure first. This is a common figure. Right angle triangle, right angle. Let's see. Given CD is perpendicular to AV, given, and this is to be proved. Data given we have written, to be proved we have written. Now directly coming to the proof part. What we need to know? Using 6.7 we can directly declare any two triangle to be similar. Here ACD is similar to ABC. ABC is the bigger one, ACD is the left portion of the altitude. And what is the data? From this 6.7 we can prove these two triangles are similar, and we can infer from this AC by AB equals to AD by AC. These are corresponding sides, right? Chalo, let us say by cross multiplication AC square is equal to AB into AD, and we can make it as equation 2. Similarly, let us take another two triangle, that is triangle BCD and the bigger triangle BAC. Same 6.7, and from equation 3 we can say BC by BA equals to BD by BC, and on cross multiplication we will get BC square is equal to AB into BD. This is equation 4. Now if you watch it carefully, in equation 1 we have pronounced the bigger triangle as triangle ABC. In equation 3 the same bigger triangle is pronounced as BAC, because please do remember this thing, whenever we are proving any congruency or any similarity, we need to follow the sequence. We cannot just pronounce the triangle as anything, ABC, BAC, CAB. No, it has to be pronounced on the basis, because we need to say corresponding side. On the nomenclature, the corresponding sides will be divided. On the nomenclature, the corresponding angles will be decided, right? So both are same, but in equation 1 and equation 3 we are pronouncing differently. Second minor details, that is what else we are getting in equation 2 and equation 4 are parts of the proving element. BC स्क्वायर इक्वेशन 4 में है, AC स्क्वायर इक्वेशन 2 में है, उसका दोनों का डिवीजन प्रूव करना है तो डिवाइड करते हैं इक्वेशन 4 को इक्वेशन 2. So we are getting BC square by AC square is equal to BA into BD by BA into AD. BA अगर nullify हो जाएगा तो we will be resting this, and which is required to be proved. I hope you like this video. Today we are just on the verge of completion and we will be soon approaching Pythagoras theorem, and that will be the last part of the video on the series of triangles, and we'll be soon jumping to an extraordinary journey of trigonometry. See you soon, and do subscribe to my channel not to miss any future video, and you will be notified when I am uploading any video. And keep preparing and make yourself comfortably ready for the board 1, which is scheduled during November. Have a nice time. Bye bye.